Right, so welcome back to the Hive. Very happy New Year, guys. I think we need to cover a few more topics on Hive. We will cover the rest of Hive. So let's start with partition. So now let's look at how we can select data from partitions. Okay. So in order to take advantage of partitions, it is more important to understand how Hive handles them under the covers. Okay. So depending on your query, Hive performs partitions pruning where it only scans a fraction of table relevant to the partition specified by the query. Okay. So Hive will do the partition pruning if the partition predicates are specified in the where clause or on the on clause in a join. Okay, so let's look at the example in the slide. Uh, if we have a table called uh, page underscore views that is partition on the log underscore date column. So the listed query will retrieve rows for just the days between 2018 2018 March 2018 03 01 and 2018 03 and 31. So now imagine that we had a year of page underscore view, which is a data partitioned into 365 separate partitioned files on HDFS. Okay, and Hive will only need to open and read the 31 partition data files for the days in the month of March 2008. Right. So if we hadn't used partitions, each time we ran the query Hive. Basically Hive would need to read all the 365 files to satisfy on our request. Okay. So just take a look at the slide. Maybe you'll get a better insight. So basically, it is depending on your query, how you will perform the partition pruning. Okay. Let's move on to the next slide. Okay, joins. See, Hive supports joins via ANSI joins syntax. Okay, and Hive supports basically inner joint, left outer joint, right outer joint, then full outer joint, and left semi joints. Okay. We list an example joints here that basically utilizes the left outer joint. Okay, and also note that Hive only supports equi joints. Okay, so Hive also has a limited support for subqueries. They are only permitted in the from clause of a select statement. Okay, and another useful Hive tidbit is that Hive is optimized to have the largest table on the right in your join query. Okay, and also the table on the right will be streamed from the disk, and the outer join table will attempt to be read from memory. So keep in mind that When you are creating your queries, the table on the right will be streamed from the disk. Okay, and the other joint tables will attempt to read only from the memory. Okay, there also is a hint that can be specified to tell Hive which table to stream. Okay, and and there is a variety of joint performance. Basically, it tricks for you to investigate. Okay, and if at least one of the join tables is small, and it is possible to do a map join in Hive. Okay, this is an interview perspective questions. So take a mind note. If at least one of the join tables is small, it is possible to do a map join in Hive. Okay, and if the tables being joined are bucketized on the join columns, and the number of buckets in one table is a multiple of number of buckets in the other table. That means the bucket that can be joined with each other. Okay, so this is called as bucket map join. Okay, so let's move on to the next slide. Before that, just take a look at the slide, please. All right, let's move on to the next slide. Order by or sort by. So in Hive, the order by clause is similar to the other version of SQL. Okay, so the order by clause performs a total ordering of the result sets. Okay, so um, although a single reducer for large data sets, this can be mean as high latency. Okay, and we cannot we can contrast that with the Hive's sort by clause. Okay, and using the sort by, this sort by clause causes the data to be ordered in each reducer. So each reducer output is sorted basically. Okay, and if there are multiple reducer, then the final result may not be sorted as desired. All right. So Hive 0.12 introduced the capability to do a parallel order by, and however the feature is still young, right? Okay, so if you are familiar with the SQL, then almost like similar looks the query looks similar. Okay, well, let's move on to the next slide. So casting. See, in addition to the implicit conversions in Hive, we will do when you compare one type to another, right? So it is possible to use the cast function to explicitly convert a value of one type to another. Okay, so in the slide in this example, basically we cast the salary, which is of string data type, to a float, right? Just take a look at the example, guys. So we use the cast function to explicitly do this. So if one of the salary happened to contain a person's name or some other text accidentally, and not a representation of a number, then I would return a null after the attempting to do the cast. Okay.
Karthik, I can't see any slides. Is it visible for others? I'm not sure. Maybe I'm lagging.
How is it? Neha or Binda, can you tell me, is that visible? It is visible. All right.
Eh, okay.
It's visible for me as well.
Okay, let me rejoin. I think my internet is very slow. I think so.
Could be. Yeah. Let's wait for him to join again. Right, Sedu. So is that visible now? All right. So that's about the casting. Let's. Sedu, is that visible now?
Yes, Karthik, I can see. Can you? Oh man, damn it.
I think you have a very low bandwidth, Sedu. But yes.
Yes, Karthik, I can either.
All right. So Sedu, you can watch the session if you want. Otherwise, you can review on the recorded session. Okay. So let's continue with the session. So let's finish up this Hive. So that's about the casting. So let's move on to the next slide. So views. Okay. So see, a view in Hive basically allows a query to be saved and to be treated like a table. Okay. Uh, a view in Hive is simply logical. Okay. So it does not actually store data. Um, in other words, just the view query is stored in the Hive metastore. That means the view query is not it is not run until we use the view in another query. Okay. uh, I hope you tried the view query in your practicals, right? So the nice thing about the using views is it can help us handle the complexity of larger queries, okay, or let's say longer queries. Here, we have an example of a query that basically contains a subquery. We can simplify this by using a view. Okay. We first create a view using the create view clause, and then we can run the another query that selects from the results of that view. Okay. So also, dropping a view is done by using the drop view statement. Okay, so we had some of the queries, I mean clauses we have practiced earlier before we completing this slides. So I hope now you will be having a good insight on how why we are operating right. All right. So let's move on to the next slide. Explain. Okay. See, sometimes it is very useful to be able to generate a Hive query plan to see what is going on behind the covers of Hive and Hadoop, right? So we can do this using the explain keyword. Okay, so while the details of the explain are a bit out of the scope of this presentation, let's check out an example. Like we see the word explain is in front of our select query. So basically, Hive outputs the explain plan, showing us the stage dependency and a bunch of other informations. Okay, uh, from this explain information, we can figure out how many map redis jobs Hive is creating to fulfill our request. That makes sense, right? All right, so let's move on to the next slide. Okay, all right. So just take a look at this explain example. It's very simple, guys. We already tried that practically. All right, so let's move on to the next slide. All right, so this is one of the important topic in Hive. Uh, in this lesson, I mean, you will be discussing about the Hive operator and functions. Okay, so after completing this topic, you should be able to use a variety of Hive operators in your queries. Okay, and and also you'll utilize Hive's built-in functions and explain the ways to extend Hive functionality. All right. So these are the basic relational operators. Okay, now let's kick off by looking at the relational operators included in Hive. Okay, the past relational operands are compared and a true or false, basically values generated. Okay, and if you are already know another SQL dialect or language or query, nothing here will shock you up. Okay, so we have an equal or not equal operator, and greater than, less than, and greater than or equal, or less than or equal operators. Okay, if you like more time to review the contents of the table in this presentation, please take a look at this slide for a while. Okay. All right, so let's move on to the next slide. So some more relational operators. There are some additional relational operators. So we can check if a value is null or not. Okay, and we can also use like and r like, basically to do a comparison on strings. We'll look at into the examples. Okay, and I hope we tried this in practical as well. Right, so in the next slide, we are looking into the example. So let's take a look at the example of a relational operator in action. Okay, so the like and r like operators are very useful, basically when you are searching string fields in your data. Okay, so I hope you understand what is string right now, right? You can understand what is integer, what is string. These are all the data types. So in the string, we are searching something. So in this example, we are searching for all the users that have a name that begins with the letter JE, right? So you can see our results basically includes the names like Jessica, Jeb, and Jen. Unfortunately, I think I missed to add Jesus' name as well. All right. So we can use our like operator in the same manner as the like operator. Okay. Basically, our like allows us to search on regular expressions, which can give us even more power over our search query. All right. Okay. Let's move on to the next one. Arithmetic operator. So Hive also contains the arithmetic operator uh, you are used to working with. All right. So allowing for additions, subtractions, multiplications, divisions, and so on. So I'm not going to explain much about the arithmetic operator in this session, but yes, you can by looking at the slide, you can understand what is all about. All right, so let's move on to the next one. Okay, let me move to the next slide. So it's a logical operator. Basically, see the following tables listed here is Hive's logical operators. Okay, these operators basically provide support for creating logical expressions, and all of them written Boolean, like true or false. Okay, and we have the and, or, and not. Basically, these are the operators which is available to us in Hive 2. Okay, you can look at the descriptions. Hope that should be visible. So the last one, not A, is a boolean. If A is false, then this returns true, else returns the false. Right. So hope you should be able to understand what is booleans, logical operator. All right. So let me move to the next slide. Right. So operators on complex types. So see. Mhm. See, the operators in this table basically it provides a mechanism to access the elements in Hive's complex types. Okay, so these operators and complex types are not likely to be found in the traditional RDBMS. Okay, so they are closer to what you would find in traditional programming language, but the array elements in Hive are accessed with the bracket notation as shown in the slide. Okay, and and a reminder that array indexes are zero based. Also here maps are also accessed using array bracket notations. Okay, and structs are accessed using the dot notation. Okay, I have three operators: a, m, and x, and we have operands, types, and some description. Please take a look at that. Basically, m operator is more on the key value. That is the key value pair. Okay. All right. So it's easy to understand, right? Let's move on to the next one. See, Hive also has a variety of built-in functions that you can use in queries. Okay, so I have listed some of the commonly used functions in the table. Just take a look at this. Um, so we have nearly 7 to 8 return types and function names, that is basically signature, and we have a description on the returns. The last one is string return type. Basically, it's gets on JSON object, and it extracts a JSON object from JSON string based on the JSON path specified, and return JSON string on the extracted JSON object. Right. So when you work on the Hive practicals in the next time, you should remember these things so that you can. I mean, like, this is just a stepping stone for you to understand the advanced level of Hive. Okay. So let's move on to the next one. So we have some more built-in functions. I have added there. Um, See, this table has a few interesting aggregate functions and some tables basically generating functions, right? So we have count, sum, and average are aggregate functions you are likely to use often. Okay, so remember, this is very important for you guys if you're going for any big data role. I mean, like any kind of Hadoop jobs or Hive responsibilities. So we'll be using a lot of count, sum, and average. Okay. And the explode functions basically allows you to take an array or map and explode. Basically, it outs the into the zero or more rows. Okay. Also, please note that there are many more functions built into Hive. Uh, Take the time to check some of them out. Okay, and you can always run the command like show functions from within the Hive CLI to get a listing of built-in functions. Okay, and you can also run the describe function command to view the documentation for that function. Okay. Right. So let's move on to the next one. Okay, Windows and analytics functions. Okay. See, Hive includes windowing and analytical analytic functions, basically that operates as per SQL standard. Okay, and I would request you to visit the Hive documentation for more detailed explanation on how to work with these types of functions. Okay. We already have worked with few examples over the class, like we did a count, a sum, average, minimum, and maximum, right? So try with others as well. It's pretty easy, so you can try that yourself. Okay, let's move on to the next one. And remember that we'll be using this windowing and analytical functions a lot in production. Okay. So we also tried partition by and order by and lot more, right? Right. So let's move on to the next slide. So built-in function in action. So we have a set of examples here. Here we have a couple of examples of built-in Hive function. Basically, to use a function in Hive, you just call it by name in your query and pass any required arguments inside the parentheses. Okay, so the first query basically uses the sum function, and the second query uses the count function. These both behave how we'd expect in SQL, right? The first one, we are having the queries select sum of numbers underscore column from our table, and the result is 15, and it is as expected. And the next one is is summing up. It's counting all from our table, right? So that's a basic one. Let's move on to the next one. Extending Hive functionality. All right. So far, you have seen some basic and advanced level of Hive, but there is something more important for you if you are looking into developer role in Hadoop or big data or data science space. See, extending Hive's functionality. So sometimes in Hive, we may want to have some functionality that goes beyond what the built-in functions provide. Okay, so we'll be using this a lot in real time in production. So it's good to know about it, and you can try yourself. It's very easy. So one way we can do this is by creating custom user defined function. Okay, that is UDF. So UDFs are implemented basically in Java. Okay, or you can say you can also create UDF in Python as well. So once your UDF Java code is complete, and you export it to your jar file and add it to the Hive session, basically where you can then use the function the same way you did in the built-in functions. Okay, so there are three types of functions, types of users defined functions. I mean to say, like, there are three different types of UDF you can create. Regular old UDFs, user defined aggregate functions, user defined table generating functions. Okay, and streaming is an alternative way we can transform data using Hive. And when we are running a streaming job, basically data is passed to an external process of our choosing. Got it? Right. So our data is basically is read and processed. Also, the results are written back out to us. So Hive has three clauses. One is map, second is reduce, and third one is transform. Okay, basically that can be used for streaming. Okay, and the streaming example here is a very basic one. We send data to the /bin/cat command, which comes on the most Linux systems. Okay, the bin/cat sorry, slash bin slash cat slash command. Basically, it's simplify the echoes the data sent to it, right? So I will get the result back and print them to the CLI command line interface. Okay, so you have now completed this topic. Um, I would request for more level of details, you can read on the official page of Apache Hive. All right. I think we have reached to the end of the slide and end of Hive. So following this, you will be having an exam now. I'll be sending you the set of questions through Google Classroom. Please give a try at that. And all the questions are very basic, and I have added the questions very carefully based on the interview perspective. Okay, so these are the questions that can be expected on your interviews. All right, so these exams have multiple choice and true or false, and basically you can take your own time. And I would request you to take a look at on the previous recorded sessions. Go over that once before you try to attempt the questions. All right. So you can have almost like 20 to 30 questions, and you will feel confident once you review the uh, previous recorded sessions. All right. So that's the end of today's sessions, and we wrapping up with Hive. So we will catch up in the next class with the new concept and new tools in the Hadoop ecosystem. All right. So thank you so much, guys. Right. So any questions so far, guys? All right. Thank you so much. Good night.